Hi there, my name is Dan Pollock. I work for a company called Data Storage Science, and today we're going to talk about building a swordfish polar. A bunch of folks have talked about swordfish already today, but we'll, go through it, right? Because the idea is that you want to make sure everybody in the room knows what we're talking about, so we'll talk about swordfish again. It's been done 3 or 4 times this morning already, which is great. Talk about what we think a polar is, right? Which some folks have different ideas about how data collection is done and what that actually is and what it's called. What we use that stuff for, right? What's the whole point of the thing? What we did, I'll leave that part to Jessica sitting in the front row. She did all the hard work. I just do the talking parts and the thinking parts sometimes. And then we'll show you a demo of what we built because that's kind of fun and it's also super dangerous. If I screw it up, it looks bad for me. And the shame and embarrassment that comes with that, right? I think it'll go well, but we'll see. And then if there's questions. So what is swordfish? And so this is just the parts that I think are interesting, right? Everybody's been through this extensively and it's well defined and all this good stuff about it, but there's some really important things about the storage management API that Swordfish provides. And so the scalability part is really important, right? And the standard part is really important. For me, those two things are what makes them useful and important rather than just kind of the sort of vague-ish standards that you sometimes see for the various things. So it's really well built, and it's in collaboration with the DMTF on the redfish side, and the redfish is also a really well-built standard, so you can see where the foundations come from on that part, and you can see where the domain-specific stuff that is required for storage as opposed to the redfish stuff that manages servers and a bunch of other things that are less well-defined in my head because I spend most of my time with the storage stuff. But the idea is that you have this well-defined standard for the domain-specific devices that you're using, and that is super important because the upstream use cases for the data are enhanced by the domain specificity because it's much more accurate, reliable, trustworthy data when you get the domain-specific data as opposed to a giant management standard that is capable of touching everything but may or may not have the in-depth sorts of awareness of those things that you really want when you want your upstream data to be high quality. And I'll talk about why you want that upstream data to be high quality a little bit later on. The other sort of interesting thing about Swordfish is it's got a really regular cadence, which is great. So the standard is updated, expanded, enhanced, refreshed on an ongoing basis, so you're not left with something stale that can't keep up with things that are new in the industry or in the environment, as opposed to something that somebody wrote once and then it's the standard, but it doesn't apply to all the things that have come since the standard was developed and shipped. So for instance, one of the things that is new in the Swordfish standard, or newer, is the NVMe support, right, and the NVMe support, and those things didn't exist as things that needed to be supported when the Swordfish standard was developed around 2016-ish, right? So those were nascent hardware things that people were not putting in servers and that people were not managing as a whole, and so having a standard that now contains those capabilities shows that the standard is both fresh and alive and helpful for folks who want to both use it and contribute to it. There's this diagram on this page here, or on this slide here, and it shows some lines going off the diagram, and it turns out that I cut those off because it made the diagram look better, but also those things are handled externally to Swordfish. So that's stuff that's handled in the redfish standard, or even theoretically external to the redfish standard, things like authentication and authorization, ACL kind of stuff, and also alert management, things like that. So those things are plumbed in, but they are handled externally, and that's why there are lines going off the diagram. But you can see from the diagram that it's an incredibly comprehensive standard, and that helps us with the data later on. The current release is 1.2.7 for Swordfish, and that was released just a month ago in August. So, like I said, really up to date, really important to have that freshness in the standard and to make sure that things are keeping up with the way industry is moving as far as swordfish goes, and as far as storage industry goes. So now we'll get into what we think a polar is. And folks have different definitions of how you do data collection. We sort of refer, the company I work for and the folks I work with, refer to polars as central data collection tools that make periodic requests from an endpoint for data, right? I'll just read that part off the slide, but the idea there is, what does that mean? And it means that we're making requests from our central thing to the endpoints that provide the data, and the reason we do that is so that we don't have to worry about delivering agents to a large number of remote entities, which can be complicated, create version inconsistencies, create management headaches as you try and maintain them all at the same version, and then try and keep some of them that are up alive and some you find that are down and they're not collecting data, and you have to go out and manage this whole fleet of agents. Agent data collection is helpful for some things at the edge. In this case, we think for distributed management, that's probably not the right choice, and so we use the polars as much as we can to collect the data from a central location by reaching out to the endpoints that have the data in order to make the process more efficient and more manageable. And you see why that is later on too, because it turns out polars kind of scale as well, and you have to kind of have a lot of them. So what are we doing with the polars? What data are we collecting that we find that's important? These are all the system details, but firstly, we look at the physical devices that we're talking to, and we get all the details of all the things that live inside those machines, the sort of what those machines are, what the contents of those machines are, environmental sensors if they exist, right? So you can figure out what power and temperature and things like that are going on, so we can collect all of that data about what the physical aspects of the system are, and those are helpful for knowing things about the health of the environment. And then the next thing we collect from the central polar is the configuration details of the systems that we're talking to, and those configuration details are important because they tell us how the system is built and how it's set up and what features are enabled, and those features tell us what it can provide as far as resources, right? So when we're looking at the data we want to pull, and we're going through the standard and saying what exists in there that we can pull out, that we can make use of, we know that we have the physical system details, right? That's all enumerated in the physical aspects of the standard. Then there's the configuration stuff that tells us how the system's built for the specific use cases that it's servicing in the environment that we have. And then one of the next thing we do is we dig even further into those systems to see what they'll tell us about the relationships between the entities that are configured through that configuration information. So, for instance, the configuration information will tell us things like there's a group of disk drives, they're in a RAID set, there are volumes built out of those RAID sets, and those volumes are exported. So now we'll look at the relationships that exist within the environment in Swordfish, and it'll tell us things like these hosts are using these volumes through these interfaces. And it turns out those are really important things to know when you're trying to figure out if something is broken or not. And it is also really important to know when you're trying to figure out what might happen if something breaks, or what might happen if you take something away, right? So the idea that we have all of these things, physical, configuration, relationship, that gets us into a pretty complete picture of the systems that we're interrogating through the polar, and we store all that data someplace safe, and we do things like check it once in a while for all the things we find interesting. I'll talk about the use cases a little bit too, but after we get all those things about the system extracted, we're also looking for conditions in the system that it's calling out that are errors, right? So we want to know, does the system think it's broken? And the polar can tell us that. And one of the useful, interesting parts about the error state extraction is that we can bypass a lot of discovery about things that are not right in the system by simply extracting the error conditions on a regular basis and sending them off to the alert system. So while there are alert systems built into the management infrastructure, and a lot of the systems themselves have ways to notify external entities of their error conditions, being able to pull those error conditions as a backup for those systems makes it really important. So when the poller talks to the systems through the standard, it gets the conditions that we find interesting, and it gives us the sort of state change that we might need to action in case something is gone awry with the system or the array or what have you, right? And then now we can look at even higher level sort of information from those standards. And another one of those things that people look at is metrics, right? Metrics are a long-term sort of data collection process, just because you want to track the system's utilization over time from a metrics perspective. And sometimes that's as simple as throughput, and sometimes it's, on the front end as a whole aggregated, and sometimes it's all the way down to the volume or device level. And the more detail you get, it turns out the more frequent you have to pull the data to make it useful to you. But it's interesting to have all that metrics data and decide which is useful to collect and which is useful to collect at high rates, and which is useful to just kind of have hanging around in case you need to go back and discover something interesting about your array that you didn't know before because you were collecting the stats, but you weren't aware of what they were, of how they were applicable to your applications and how they might be useful in troubleshooting those applications. And so the last thing that the poller can do, the way we build them, is they can do basic comparisons across runs, so you don't have to go into the data store and run jobs that do data analysis and then extract the interesting aspects of those change states and then send them off to the people that might need to know them for either reporting or alerting or event management or any of those things. So the poller itself can check the data for state changes across those different runs, and depending on how frequently you do that, you can decide what's important and what the sort of minimum notification period is. But that's the idea, is that you can run those comparisons, and then if you find something of interest that is anomalous, you can then do immediate alert notifications as a backup, theoretically, for the event notifications that would come out of the system automatically and whatever other alert management infrastructure you're running. So the poller itself acts as a backup for all of those things. So that's what a poller is, right? It's not just get the data, put it in the data store, move on with your life. It does all of these interesting things. And so we have a bunch of use cases for the poller data, and it turns out they're super important because without this data, a lot of the customers that we work with can't actually run their environments in a meaningful way, right? They can see that their systems are running on a regular basis, but without the data that we get from the pollers and put in the central data stores, they cannot actually operate their environment, right? So there's the ongoing sort of steady state stuff that just kind of happens, and they're fine with that. But the poller itself is important for a ton of data collection that supports a ton of use cases outside of just the operations of the environment. So one of the first use cases that we've ever dealt with, and this is back when we started writing pollers 20 or 30 years ago at different companies, and the idea is that configuration management is incredibly important to the operations groups that run the systems that are responsible for the interfaces between different systems, right? There's compute and storage and maybe network, and so having the configuration management information, right? Originally, our pollers supported what were called CMDBs, configuration management databases, and the idea would be when you were looking at the configuration, you could keep track of system changes, and those are really important if somebody makes a bad change. But they're also really important if just matters of historical fact, so that you can say, well, this system has had this provisioned and unprovisioned and reprovisioned and unprovisioned and reprovisioned. Why do we keep doing that? Is there somebody making requests and somebody making removal requests and somebody making reallocation requests? And so the idea would be that you want to track the configurations in the configuration management use case and then perform reporting, but also do occasional looking in case somebody says like, oh, you know, this configuration was one way before, it is now this way, how did it get that way, and why is that important? And those questions come up for the operations teams all the time so that they can do a better job of both minimizing the amount of work that they have to do to manage their systems, but also discovering things that have gone not quite right, like configuration drift from operational standards, but also when people do things that aren't within the proper scope of what they're supposed to do, right? Because people touch these systems once in a while. Sometimes automation is the standard way to do that, and you want to know if somebody has done something manual that is different than the automated way in which it is performed, and the configuration management aspects of the Polar and the database are what uncovers that. One of the other things that configuration management data gets you is the current state of your systems, like firmware. Turns out that's another really important configuration management case, and keeping firmware up to date is a non-trivial exercise because you have to deal with the way in which the devices that you manage both do firmware updates and the customers that you consume those devices tolerate the behaviors that occur during updates to those systems. So if you have to take it offline, most of your customers tell you you can't do that, so you have to be able to sort of reallocate resources. If you don't have to take it offline, but there is a performance degradation, people need to know about those kinds of things. So being able to track those changes from a configuration perspective and see not just where everybody is, but how to plan those operational behaviors so that you minimize the impact on your customers is kind of where the configuration management aspects of that use case come from. Another use case that we have is event management, right? It's a thing that people once in a while call observability. It's sort of murky how those things differ, but the idea is that you want to get a look at what's happening when an event occurs, right? And so when we're polling the data, we can see what the prior state of the system was before the event occurred, and that assists us with event management when we're looking at this historical data, and it gives us the ability, like I said, to do things like what-if scenarios, right? If I take this interface offline, what will happen? What resources will be affected? What end users will be affected? And without the Polar data, you can't look at the configurations and you can't see. And so I'm sort of glossing over that there's a data repository behind the Polar, but the Polar does all the work to get it in there. And the idea is that the use cases are supported by those things that you do, right? So the other thing that happens is when defects occur, the event management gives you a better insight into what's actually going on as far as the effects of the defect on the external consumers of the system. And then there's resource allocation, right? So when we're polling the system as a whole, we need to know what it has available, what is consumed, and then how to make the right decisions about where to allocate resources next. So when I'm looking at the global fleet of devices and I see that I have capacity here and I don't have capacity there, I might automatically decide that I want to allocate capacity from the system that has what looks like capacity free. But the other thing that you can do with the resource management components as you poll the systems and gather all the data is you can say things like, well, that capacity looks free, but there are other resources that are consumed, like performance or network interfaces or all of those interesting things, right? So resource allocation is supported by the Polar data as well. Then sort of the higher level aspect of the resource allocation problem is the capacity planning problem, right? So now I'm not allocating resources immediately, but I'm trying to plan for how resources are going to be allocated and what I'm going to do to my systems environment as a whole, and the whole data supports all of those decision-making processes by collecting this data on a long-term basis, and also allowing you to do things like apply business rules to the capacity planning cases that you guys may or may not have in your environment, right? So, for instance, one of the things that we used to do is plan for lease return replacements of devices, and you have a time horizon for doing that based on how long it takes you to get the device that's going to do the replacing, plus how long it takes you to migrate the data, and how much capacity you have in the environment, and how much capacity you need guaranteed in the environment, and all of those things go into the capacity planning thing, the capacity planning process. And without the data coming from the pollers, you can't know things like, oh, we have the 80% threshold that we require for free space, and we have the data migration history for these systems, so we know that we can move them in a week or a month or 2 months, and we know how long all of those things take. So when we're looking at the data as a whole, we look at it from a capacity planning perspective as well. And then one of the more recent use cases that has become incredibly interesting to our customers is the technology business management or financial management use case. And it turns out that because we've been collecting all of this data all along as part of configuration management, and we have all the relationships either polled or defined within the back-end data stores, we can give the people who rely on the sort of financial aspects of the business more insight into how the systems are consumed by individual business lines or systems or whatever your company uses to allocate resources at the financial level. So having the ability to know that this virtual machine uses this storage and belongs to this business line is a really important thing for folks who are worried about the financial state of their company, and that's the whole notion behind technology business management. And the pollers gathering those relationships enables that functionality in a very straightforward and clear way, which makes the financial folks that we deal with very happy, and it also gives the business owners more insight into the burdens they place on the business so that they can do things like discover where they've either over-allocated resources or allocated resources in a way that is not how they want for their business to operate properly. So that's the sort of use cases that we look at when we're trying to gather the data through the pollers so that we can support all of these different things. So when we're looking at the standard, which has all of the information that we want to collect, we can collect all of it, but we want to be able to flag the important data so that we know how to prioritize when we're building the poller. I want to get the environmentals, I want to get the relationships, I want to get the information that supports capacity planning and resource management, so we get all of those things, and having the well-defined standard gets us to all of those use cases, and we don't have to discover anything or dig around or be uncertain about whether or not we have the right data, because we've looked at it and we know exactly what we're getting out of it when we know where we're polling. So alerts, once again, that's the thing I talked about, but it's a really important use case as well, right? Where the poller provides backup for the primary alerting systems, right? So I wouldn't say that with the poller you're getting the alerts that you want immediately, but the idea is that if for whatever reason the systems that are primarily responsible for delivering those alerts don't or can't because they're broken in some other way that's a side effect of the system defect that you're worried about, if the poller still works, it will tell you things that you may or may not have noticed and that may or may not be as obvious as you would like them to be. And so you can do things like find devices offline, interfaces offline, changes in state, things like that, and getting those from the poller directly acts as a backup, like I said, and it turns out having multiple sources of both data and supporting those functions gets you a really valuable set of redundancies and backups, and your data, you're polling the data anyway, so having that secondary or tertiary alert support really builds confidence in the back-end systems when people are worried about how they're managed. Then obviously, like I said, there's a big data repository. You can keep this data for the long term. The long-term data retention is generally just supporting historical information about the systems. If there's infrequent change, then you really don't know what's going on, but you can always look back in the history and say, oh, this is a reasonable thing to do to a system because the history that it exists in the data repository and that the pollers are showing me is saying, you know, this is something that we've done before and this is something we can do safely again. The other thing about the long-term data collection is that occasionally entities, enterprises will lose institutional knowledge through retirement or employee changes or things like that, and having at least the physical state of the systems in the long-term data collection repositories gets you that institutional knowledge support that in a lot of ways people can find very helpful and useful, especially in the operations kind of areas of the systems, but also in the why did we make these decisions 3, 5, 7 years ago as far as financial or resource allocation kinds of things, and all that stuff is supported by the data that comes out of the pollers and goes into the long-term data repositories. So the last two statements here are just kind of interesting because we do this work a lot. It turns out that the desire to collect the data from the systems that you run is both incredibly common and incredibly difficult for most enterprises. The traditional sales pitch looks something like, we will sell you this system and we will sell you this magical management interface to this system, and it will cover all the things that you need to know. And most of the time, coverage is only limited to what was sold from a single vendor. And if you're lucky, it's multiple vendors, but not all of the ones that you have. And that's problematic. And the other problem with that is that getting the same data from multiple data sources through multiple different views makes the data more reliable and more valid. So in the case of the software footprint data that we poll at some of these entities, we can look at how the different software management entities account for things like licenses and installations and things like that. And when we get good agreement, we're pretty sure that data is correct. And when we get disagreement, one of two things can happen. Either the system is in a state of change where things are being removed or added, and that's why the two systems disagree, because they kind of catch up to the data current state at different rates. But we can see that and then go figure out what's happening there. Or there's definitely a defect in the system somewhere and you need to go repair it, right? So that's why having multiple pollers is important, but also having multiple views of the data is important. And we build a lot of them, and it's remarkable how minimal coverage actually is for any given system when like I said, the sales pitch is generally this management tool with all of this data covers all of your systems, and that's rarely true, which is why we need to build pollers in the first place. And then the second statement is sort of really important because the standards-based pollers have wider coverage. So everybody who participates in the standards group is compliant with the standard theoretically, delivers it with their product, and allows you to use that interface instead of the proprietary interface or no interface or whatever you're getting to. And the idea there is that it is less effort and you get better coverage to get the poller that handles Swordfish storage management done than it is to touch the management APIs for vendor A and vendor B and vendor C and vendor D even if they are all Swordfish participants, they may have different feature sets, and that's 4 different polars unless you use the Swordfish one, and then you get all 4 covered. And the only downside there is you may not get unique features that are not covered in the standard, but you can deal with how you want to manage those, but you're at least getting uniform data from all the other things. And then the other sort of interesting bit here is that not everybody has a sort of proprietary API that fits into the standard tools that you're using. So we have commercial tools at a bunch of our customer entities, and they have sort of 80% coverage on average of the types of devices they manage. And that's not great because we still have to go off and write the polars that then cover the rest of the environment. So theoretically, and this is the goal in the future for us, is if we rely and request and require, assuming we have enough influence to make it a requirement, we can require that the devices that are in use always support the standard that we use for data collection, and therefore never have to worry about on day one getting the data into our systems that we rely on to both operate and manage the environment for all of these different use cases, right? And so that's incredibly important. That being said, commercial tools that support Swordfish don't seem to be that common. So we're going to keep working on ours, and eventually we'll do our best to make it available in a meaningful way. It isn't clear to me, the standard's been around for a really long time, why that is. There are no real commercial implementations that we can find, at least from the polar side, that integrate with other things. But we'll, like I said, we'll see what we can do about getting ours into the world, and we'll see what we can do about getting the coverage for at least the polling, the data collection part, right? There are obviously a lot of other back-end moving parts, but that's the idea, is that if we can get that done and we, are successful, then we'll effectively have many fewer data collection entities to manage while getting all of the data that we want. So I'm going to let Jessica talk about the what did we do part, and then I'll come back and do the demo.
Good morning. I am Jessica Bresnahan. I am the developer and college student that built the Polar. So pretty much what I did was already built off of the existing Flask framework that the Swordfish emulator runs on. And I added an endpoint within the emulator that once it hits it, it starts running its own custom Python functions. And it pretty much traverses the tree and then individually requests each endpoint that we are trying to pull out and get that data from. And then it loads the JSON, parses out the important bits that we want, and then also does secondary analyses. And then we'll return a final, more detailed JSON output. So I'm going to move to the diagram and kind of elaborate with some more. But so we were requesting from the top of the hierarchy. So for example, like a resource that would be at the top of the hierarchy would be like the chassis, and then the enclosures, and the drives, individual drives, and then all the information that the drives have, along with like attached volumes and storage capacities and things like that. So once the functions are done running and all that information is collected, it formats it, and then again starts to do a secondary analysis. So what we are kind of pulling out that secondary analysis is every time it runs, it stores that data that it pulls out from the most previous pull, and then stores it so when you run it again, it runs against that data that was just ran, and then it compares stuff like drive serial numbers, volume serial numbers, port changes against that, and then it will flag it for any changes. So once that is all done, it reforms what we want in the final output with the data that we didn't change but just pulled, and then adds in that secondary analysis in that data to return a more detailed output for display, and that it returns it as a JSON response. And in that response, it includes like the drive consumed allocated capacities, the volume consumed allocated capacities, ports, and like I said, detect the changes within that. So I am going to hand it back over to Dan to do the demo. Thank you.
Thanks. Because we are working with the emulator and not with live hardware, I basically modified the emulator, not just in addition to the modifications Jessica did to do the polling and the data collection, the data analysis, but also to make the emulator more interesting. So our emulator is much bigger and has data changes and some other interesting things in there. But we would love to be able to use it with real hardware. So if anybody out there has hardware that we can touch just to poll it and make sure that our pollers do the right things, and then enhance our pollers with additional data sets, right? We can do that. We're happy to do that. We'll work with you. If you'll let us this year, I guess there's no Swordfish Plugfest, so I'll figure out when I can get that done. But like I said, anybody who's got hardware that will let us use our pollers with it, we're super excited to give that a try and just let you know how that goes. And also it'll help us to add use cases to the data collection and maybe even provide service if there's defects that may or may not be aware of in the systems themselves when they respond to the data polls. So anyway, now's the tricky bit. I'm going to see if I can make this happen. Maybe I can. Maybe I can't. Let's see, can I change pages? Okay, so there's the interface to our version of the emulator. And you'll notice down here at the bottom, here, let me just make this bigger. There. So down here at the bottom is the bit that causes Jessica's add-ons to run. So we'll go ahead and run them. It's much faster on my computer, so you guys may have noticed her fancy little fishing animation, right, while it's polling. But so here, now we've got all this data, right? We enumerate all these devices, and it turns out there's about 1,300 lines of JSON, and it's incredibly ugly and unpleasant, and this is the part where you get into how do we use this data in a really interesting and valuable way. And it turns out that we talked about how we wanted to present this data, and so now we have the data that we would use sort of as an example of the information that we collect and why we find it interesting. And so first here is the array capacity data, right? So we can see how big the array is from a raw capacity standpoint, how big the array is, or how free the array is from that raw capacity standpoint, and how much is allocated. And it turns out that we track those numbers over time, and those things feed into the resource management and capacity planning aspects of the polar data. And so that's the first part, right? And so the second part is these relationships that I were talking about, right? So we have 4 hosts. We have host called host, and then proton, neutron, electron. We know that they use 2 interfaces to access the data. We know that they have 2 volumes apiece, and then we know what the capacity of those volumes allocated is. And theoretically, we can discover what the consumed capacity is, assuming the array reports that back to us. I did not modify the emulator to deal with that. But the idea is that you can know all of those things about the relationships within the system that you're talking to through the polar and then through this this presentation, right? And then, so here's some more stuff we've done, right? The emulator comes with a couple of devices configured. I configured 24 of them. The emulator has this other context in which the drives are displayed, and it shows not just the physical drive aspects, but the ways in which volumes are allocated out of the drives. These are NVMe drives in the emulator, so they basically look like NVMe namespaces. That's not super important, but that's what we're seeing here is the amount of data allocated from these drives as volumes, and then whether or not they're exported, and that's what's going on there with the enabled column. We have an enumeration of the endpoints, and that's just useful for the relationship data. We've got some state change flags here and here. And the idea there is that we can detect state changes across polar runs and flag them there, and then the device would theoretically send an alert based on those state changes. And what looks like here is that I left the emulator in a mode across runs that now shows that one of the storage serial numbers has changed. And so that's what this true flag is, right? So there's a state change flag that says something has changed, and that's true. And then it tells me down here which drive has changed and says IP attached drive 5 has changed since the last run. So I know somebody has done a drive swap theoretically, right? So we're basically just comparing serial numbers, and off we go. And lastly, we can see the sort of transport details and the interfaces. So if I come over here and make an interface go down and rerun this, we get the same data again, but theoretically now I see a new state change. The old state change is gone, right? So that drive hasn't changed across runs, so I know that that state change occurred and I sent the event or whatever happened, but across the next run, it's the same drive as it was the last time I ran it, so it doesn't get a state change. However, it did notice that now I have a link down. And so that flag has gone to true, and that link has shown up as the link down. And so now I can send an alert based on that. And that's sort of how the polar works, right? And so if I make it up, and if I change the drive back to the original, oops. And then we rerun the polar. And if I've done this right, maybe I haven't. So, oh, I didn't bring the interface back up, that's right. Yeah, I screwed that up. Thank you. So now, we'll rerun it. Take a look at it. Oops, I missed. But now it shows all my flags are back to false and the link is up. It would have shown the state change if I hadn't rerun it, but that's the idea. So now I have my links up and none of my drives are changed and everything's back to the way it was, and that is our demo. Thanks. Are there any questions?
So is the add-on in like a GitHub repo or something like that where we can look at it, or?
You're talking about, so the question is there an add-on that we wrote in a Git repo? So you're talking about Jessica's add-on for that? Yeah, so we can make that available. It's not in a public Git repo, it's in a private one that we have at the office, but sure, if you have interest, we're happy to share what we've done. Question over there.
First, thanks for using the emulator. What would you like to do as next steps?
So, like I said, as next steps, I want to run it against real hardware, as much of it as possible, and then get that real hardware into at least the list of here's what we can do from a data gathering perspective, and then make that publicly available so people can say, this is a Swordfish Polar. If you just want to collect data from any of these systems that we validated against, here you go.
Okay.
And we have some plumbing that'll get us to depending on what your back-end data repository is, here's how you put that into the data repository. So if you're using ServiceNow, right, is one of the goals that we have. It's not done, but it's on the to-do list. And that's like the 800-pound gorilla in the environment, right? Everybody uses it for their configuration management and all those things. And they currently support common information model storage management, but not Swordfish as far as I can tell. So they sort of do it, but not this way. And we want them to do it this way because it's better.
Okay, so I see a handful of different things that we can do. One is, I'd like to get, and Jeff talked about this a little bit this morning, is I'd like to see if we can extract and help understand exactly what data you're using and maybe to help drive some demand on the device side, create what specific functions you're looking for. Create a profile specific to you to say, this is exactly what we want the devices to, what information we're looking for. So we can help with that. And then second, the one thing I can offer up, and I can get you access through the SNIA Storage Management Interoperability Lab. I can point you to a host-based implementation that talks to actual live running NVMe drives. And it'll work really well with your current Polar. It's read-only, but it will give you trending capacity information.
Yeah, so it's interesting that you mentioned read-only, right? So we think read-only is very, very important,
Yes.
right? Being able to manage the devices
Yes.
is a separate problem for sure, right? We take the data from our read-only, but read-only is much safer, and read-only is much easier, and the stakes are much lower, right? So for us, we always split data change stuff
Yeah.
from data collection stuff.
So I can
Great.
do read-only management of NVMe drives on Linux devices right now.
Yeah, and read-only is perfect.
Yeah. So this is also coincidentally derived from the emulator, but runs on Linux. I'm in the process of pushing it out through the arcane Intel open source process, but it's something that I can work on accelerating and will eventually be made open source and push out through multiple processes. But right now we can make it available through, we have it running. And it passes Swordfish CTP, posted on the website, for what that's worth. It's not a product, but it just runs against anybody's NVMe drives.
Yeah, and so that we're just looking for more coverage
Yeah.
so that we can demonstrate that we've got that coverage and then get folks more useful.
This is what I would have had to offer you as, you can run this against, I've had it running against Micron, Solidon, and Samsung SSDs already. And so, we can definitely run your Polar against this. And since you guys aren't looking at events, it's exactly the right target to, from an NVMe SSD perspective.
Yeah, and so that's one of the things we're looking for. And like I said, we're going to see if we can find storage array vendors as well who let us touch their hardware with the same read-only capabilities so that we can say, look, we can't break anything because we don't change anything. We just want to make sure we can read all the data that we need in these use cases so that we can support all that great stuff that we do. And that's kind of where we're at.
Okay, so if I can take one more minute and put it in, we'll plug it in. SNIA has changed our membership models for the next fiscal year, and I know in the past it has been insanely expensive to join, and especially on the client side, to participate with our interoperability labs. Moving into FY25, that is no longer the case. I encourage people to go out to SNIA.org/membership and check out the new membership models, because there is no longer the incremental fee once you join SNIA, that's it. And there's no longer the incremental fee to join SMI and to join the lab. It is going to be just the single price to join. So you can join and participate in the interoperability lab for as low as the still.
And you can log in and talk to real hardware.
Great.
Yes. So.
And we can turn that on today.
Yes.
I will make a business case for it, and I will call you.
The nice thing about the change of the model business case is it's free.
Yep.
And you
It's
get,
included in the review.
it's included in the membership. And it gives you access to real vendors' hardware.
Yes.
Thanks. All right, so that's our time. I hope you all enjoyed it. Here, please take a moment to rate the session. Thank you very much.